Hello everyone, welcome to the session. I am Sudeshna, Assistant Professor of CSE Department. In this session, I would like to discuss about page replacement algorithms of operating system course. Now let's see what is page replacement algorithm. Now before going in detail about these types of algorithm, first of all let's know some basics like what is a page and what is a frame. So page is nothing but the logical memory, that is the memory generated by the CPU, is actually divided into some fixed sized blocks called pages. Now next, the memory, physical memory, the main memory is divided into some blocks, fixed size blocks, and we call those blocks as frames. Means imagine that this is your main memory and the main memory is divided into equal sized blocks. These blocks we call it as frames, and if you observe, one block is completely dedicated to the operating system to save. Now the remaining blocks we call it as frames, so I am calling it as frame 1, 2 and so on. So main memory is divided into frames, and the address, that is the memory generated by the CPU, we call it as logical memory. So that memory is divided into some fixed size blocks and we call it as pages. Means imagine that you have a process and that process is divided into some pieces. Those pieces are called as pages. Now your task is to save these pages into the frames of main memory. Means if you want to save your program or process, then these pieces should be saved into mapped frames. Means page 1 should be saved into frame 1 likewise. So this is called as mapping, saving of pages into frames. Now the thing is, when this page is saved in this frame, that is when you are trying to save this page into frame, first of all you have to see whether the frame is available here or not. Imagine that I am trying to save this page 3. Now before saving you should see whether page 3 is already there or not. If it is not there, then it is called as page fault. Means the required page, if it is not there in the main memory, then it is called as page fault. If page fault happens, you should see whether you have any sufficient space to have to store this page 3. You don't have sufficient space. In that case, what you have to do is, out of all these 5, you have to remove one block's data out and you have to save this inside that block. So you are removing one out and you are saving in that particular place. Now which one you have to remove out of these 5 means it is completely based on page replacement algorithms. So this is called as page fault and page replacement algorithm. Now let's have a look at page fault. If the required page is not in the main memory, then it is called as page fault. If page fault happens, then we have to go for page replacement. Means which page you have to replace. Means you have to select a victim. That victim is selected based on the types of algorithms. And one more thing we have to remember, we just learned that memory is divided into fixed size blocks called as frames, and the logical memory is divided into fixed size blocks called as pages. These are fixed sizes and these are fixed sizes. And one more thing, the size of page should be equal to size of frame. Means these two sizes should also be equal. So that's what. Note, page size should be equal to frame size. That's a condition. So this is introduction to page replacement algorithms. Now let's see the algorithms one by one. Now let's see the first one. The first algorithm we have here is FIFO, that is FIFO page replacement. In short, we call it as first in, first out page replacement algorithm. Now from the name you can easily guess that the page whichever came first will be going out first. Now I'll show you one example here. Now for this example, I took a reference string, that is a string of pages that you have to store in the frames. So these are the string of pages. So I'll call it as reference string. Now you have frames. Now if you'll observe, there are 3 frames. Like in our previous example, we have 5 frames there. Now in my memory, only 3 frames are there. In these 3 frames, I have to save this entire string of pages. Now let's see how they are saved. And while saving, you should also count the number of page faults you are getting. Now just let's start with this. Now first page I want to save is 7. Now before saving 7 into the main memory, you first see whether 7 is already there. It is not there. It means that it is a page fault. If it is a page fault, you should see whether enough space is there to save that number. Yes, space is there. So I'll save the 7 here in one of the frame. Now next thing is, next I have to save this 0. Now 7 is already there. Now I want to save this 0. Now just see whether 0 is already there or not. It's not there. So it's a page fault. Now it's a page fault. So for that, what you'll do is, after once the page fault is there, you should see whether enough space is there for saving 0 or not. Space is there. So I'll save 0 in the second slot. So this is done. Now the next thing is 7 and 0 are already there. Now I am trying to see whether 1 is there already or not. It's not there. It's a page fault. Now it's not there, so space is there. You can save that here. Now the thing is, next I want to save 2. Now to save 2, first of all, already 3 frames are given. All the 3 are occupied now. So 3701 is there. Now you should see whether 2 is already there in this or not. It's not there. So it's a page fault. So what you have to do is, you should see whether you have place for placing this 2 in the frame or not. There is no place here. Already 3 pages are there in 3 frames. Now where you will place this 2 means, out of these 3, you send out the page which came first, that is first in first out. Now out of these 3, that is 701, which came first into this frame means 7 came first. So remove this 7 out, that is first in first out. The first to come is 7. So first should be 7 should be going out. So I will remove 7, in place of 7 and place 2. So it is 2, 0, 1. Next I am searching for 0. Now search for 0 whether it is already there or not. It is there. It means it is not a page fault. Now it is not a page fault. It is already there. So I will just write out as it is. Now next I want to place 3. Now 3 is already there? No, it's a page fault. Now to place 3, I should remove one of the page which came first. Now let's see which came first, that is 0, 2, 1. Now out of these 3, which came first? 0, 2, 1. So we have taken 0 first. After 7, the next element to come into the frame is 0. So 0 came first. So you have to remove 0. Now in place of 0, I am going to place 3. So it is 2, 3, 1. Now the next thing you have to save is 0. Again see whether 0 is there or not. It's not there. So it's a page fault. Now 0 should be placed in what place means, out of these 3, whichever came first. Now let's see the sequence. Now 1 came first, then 2 and then 3. So 1 came first. So 1 should be removed. So it will be 2, 3 and 0. Next is 4. Now 4 should be placed. It is not there already in the memory, so it's a page fault. Now to place 4, I should remove out of these 3 any one which came first, that is 2, 3, 0. Now just see the sequence. 2 came first, 0 we have removed. In place of 0 we place 3, and then after that we place 0 just now. So who came first? 2 came first. So instead of 2, I'll place 4, 3 and 0. Now let's see how many page faults we got. 1, 2, 3, 4, 5, 6, 7. So the total number of page faults we got is 7. So this is FIFO page replacement algorithm. Now we have to remember one thing here. It suffers from a drawback. That drawback is called as Bellardi's anomaly. We should remember this name. So Bellardi's anomaly is the major drawback of FIFO page replacement algorithm. Now what does this anomaly says? Now it says that, imagine that you are taking the same string and we took 3 frames. For 3 frames we got 7 page faults. Now if I'll increase the frame, that is from 3 to 4, number of frames if I'll increase to 4, will the page fall should be less or more? We'll imagine that if the page frames are increased, page falls will decrease. But in FIFO, in some cases, even if you'll increase the frames, the page falls will also increase. That is seen only in FIFO, and that is called as Belladis anomaly. It says that the page falls rate may increase as the number of allocated frames increases. So actually it should decrease, but in Belladis anomaly it is increasing. Now let's see an example of this Belladis anomaly. Now I'm taking a reference string here given, and for same reference string I'm solving using two sizes of frames. One is 3, another one is 4 frames. Now let's see how many page falls you'll get for 3 frames, how many you'll get for 4 frames. Now for 3 frames, let's see how it is showing. Now I'll just do it fastly because already we have learnt it here. Now for 1 is not there, it's a page fault, so I'll say 1. Next is 2 is not there, it's a page fault, so I'll say 1 and 2. Then 3 is not there, so I'll say it is 1, 2, 3. Now I want to place 4 out of these 3. So the one which came first I'll remove first. That is 1 came first. So I'll remove 1. In place of that I'll place 4. Then 4, 2, 3, it was a page fault. Now 1 I want. So out of 4, 2, 3, 2 came first. So instead of 2 I'll place 1. So 4, 3, it was a page fault. Now I want to place 2. Out of 4, 1, 3, 3 came first. So instead of 3 I'll place 2. Then 4, 1, 2, it was a page fault. Now 5. To place 5 out of 4, 1, 2, I'll replace with 4 because 4 came first. So it is 5, 1, 2. It's a page fault. Now 1 is already there. It's not a page fault. So it is 5, 1, 2. Next 2 is already there. It's not a page fault. So it is 5, 1, 2. Next is 3. Now 3 is not there. It's a page fault. Now 3 should be replaced. Now which one you will replace means 5, 1, 2, which came first into the memory. So if you'll observe, 1 came first, then 2, then 5. See here, 1 came first, then 2, then 5. So I'll remove 1 here. So it is 5, 3, 2. Next is 4. To remove 4 out of 5, 3, 2, I have to remove one thing. That is 2 I'll remove. So it is 5, 3, 4. It's a page fault. 5 is already there. It's not a page fault. So it is 5, 3, 4. Now let's count how many page faults we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 page faults here. Now let's see the same example with 4 frames here. Let's see how many page faults we get with 4 frames. Okay, now let's see the first number we have to place is 1. So it's a page fault, it is not there, so I'll place 1. Next 2 is not there, it's a page fault, I'll say 1, 2. Then 3 is not there, so it is page fault, 1, 2, 3. Next 4 is not there, I'll say 1, 2, 3, 4. Now the first thing is 1. So 1 is already there in the memory, it's not a page fault, so it is 1, 2, 3, 4. Next 2 is already there, it's not a page fault, so it's not a page fault. Next 5. Now to place 5 out of this 1, 2, 3, 4, you have to remove the one which came first. Now which came first? 1 came first. So remove that 1 and place 5 in that. So it is 5, 2, 3, 4. So it was a page fault. Next is 1. 1 is not there. So out of 5, 2, 3, 4, who came first? 2 came first. So in place of 2, I'll place 1. So remaining 5, 1, 3, 4. So it's a page fault. Next is 2. In place of 3, I'll place 2. So 5, 1, 2, 4. It's a page fault. Next is 3. Now which came first? 4 came first. So it is 5, 1, 2, 3. It's a page fault. Next is 4. Now out of 5, 1, 2, 3, 5 came first. So I'll remove 5. In place of 5, I'll place 4. So it is 4, 1, 2, 3. It's a page fault. Next is 5. So 1 came first, so in place of 1 I will place 5. So it is 4, 5, 2, 3. So this is a page fault. Now let's count the page faults here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got 10 here. Means, just observe, same string I took. Here 3 frames if I'll take, the number of page faults you get is 9. And if for the same string, if I'll take 4 frames, the number of page faults you get is 10. Actually, if the number of frames are increasing, page faults should actually decrease. But here in this case, page faults also increasing. This phenomenon is called as Belodis anomaly. So this is seen in only in FIFO page replacement algorithm. So this is the drawback of FIFO page replacement algorithm. Now we'll see the remaining remaining page replacement algorithms in the next video.